Okay, we are still at extremum problem, how to find extremum point. So you have already seen how to do how to find extremum point by using first derivative test, which is first derivative test table. So the second method is to use second derivative test method. Second derivative test. Okay, nama pun second derivative, obviously we are going to find our second derivative. Okay, so the first step here is we have to find our first derivative first. Okay, apa yang kita buat dekat dalam first derivative test tu, benda yang sama lah kita akan ulang. Then we are going to find stationary point. Stationary point, which is how to find our stationary point? F prime x must equals to 0. And the third step here is we are going to find our second derivative. Okay, so second derivative here, we have three cases. Okay, the first one, if we have our second derivative, if our second derivative is greater than 0, therefore that will be our minimum point. Okay, if our second derivative is less than 0, that will be our maximum point. Okay, how about if our f prime x, our second derivative, is equals to 0, therefore our test will fail. Okay, test fail. Therefore we are going to go back to our first derivative test table. Okay, first derivative test. Okay, so that is step 4 lah. Alright, so ingat kalau greater than 0 dia ialah minimum, less than 0 dia ialah maximum. Dia macam terbalik lah. Okay, so let's see example 6 here. By using second derivative test, okay? If the question asks you to use second derivative, you have to use second derivative. If the question asks you to use first derivative, use first derivative. If the question doesn't say anything, terpulang mana satu yang senang untuk kamu. Okay, so now let's see. Our first step here is to find our first derivative first. Banyak betul first. F prime x is equals to 3x square minus 6x minus 24. Second step here is to find our stationary point, which is when f prime x is equals to 0. So here we have 3x square minus 6x minus 24 equals to 0. Remember, quadratic equation always simplify first. So we will have x square minus 2x minus 8 equals to 0. So now just use your calculator, your amazing calculator. For 2 minus minus, we have x equals to 2, x equals to 4. Okay, so therefore we have our stationary values, stationary numbers. So now we want to find our stationary value so that we can have our stationary points. Okay, make sure kamu tahu apa yang saya tengah cakap. So sub our x into the original function here. So f2 is equals to 2 cube minus 3 2 square minus 24 2 plus 32, which is here you are going to get here is x plus 2. So here is x negative 2. Negative. Okay, so negative 2. So here is 60. So substitute 4 into the function, substitute lah sendiri. Here we are going to get negative 48. Okay, so we will have negative 2, 60 and 4, negative 48 are our critical point. Okay, ataupun stationary point. Stationary point. Alright, so now let's move on to the next steps. The third step, which is we are going to find our second derivative. Okay, so here to find second derivative, obviously you have to use this part here lah. Okay, balik semula kepada part ini. So second derivative, differentiate 3x square minus 6x minus 24. That will get you 6x minus 6. Okay, so 6x minus 6. So to get this one here, to determine whether it is greater or less or equals to 0, we have to substitute our value. Okay, here, sorry, bukan value, numbers. Okay, ataupun value of x kita. So here we will have f prime x negative 2. So substitute here 6 negative 2 minus 6. Here we'll get negative 18. Okay, negative 18. Which is negative 18 is less than 0. So less than 0, that means that will be our maximum. Okay, so something about negative 2 is maximum point lah. So substitute the other value, which is 4. So 6 multiplied by 4 minus 6, that will get us 18. So 18 is positive, greater than 0. So that will be minimum. Okay, so now we can conclude. So this value is negative 2. So negative 2 pasangan dia apa? 60. So negative 260 is a maximum point. Is maximum point. Okay. How about 4? 4 pasangan dia ialah negative 48. 4 negative 48 is minimum point. Okay, is minimum point. Okay, so that is how we use second derivative. So to compare first derivative and second derivative, obviously saya rasa second derivative lagi senang, but you have to know your first derivative. Why? Because, okay, let's see example 7. We want to use second derivative sebab kita kata second derivative senang, ataupun sebab soalan ni cakap lah. So the first step here is we want to find the first derivative first. Banyak betul first ni. So the first derivative is 4x cubed minus 12x squared. Alright, so we find our stationary point. So to find stationary point, f prime x equals to 0. 4x cubed minus 12x squared is equals to 0. So factorize 4 ataupun factorize terus 4x, we are going to get, ataupun 4x squared pun boleh, x minus 3 equals to 0. 4x squared equals to 0, x minus 3 equals to 0, x equals to 0, x equals to 3. Okay, make sure ini tak ada masalah untuk kamu buat. Okay, we already have our x, and then we want to find our y. Just sub into the original function. F0 is equals to, obviously, 0 lah. Okay, F3 is equals to 3 power 4 minus 4 3 cube is equals to negative 27. Okay, so we have 0 0 and 3 negative 27 as our stationary point. So make sure you write this so that tak ada masalah untuk kamu tulis apa satu point kamu. Okay, apa maximum or minimum point. So now the third step is we have to find our second derivative. So second derivative, where is our first derivative? Here. So differentiate this one lagi sekali. We will have 12x squared minus 24x. Okay, so now we are going to determine whether it is greater or less or equals to 0. We have to substitute these two values first. So let's substitute 3 first. 12 3 square minus 24 times 3, that will get us berapa? 36, which is greater than 0. That means it is a minimum. Okay, 3 is a minimum point lah. Okay, how about if we substitute 0? Obviously, kalau kita substitutekan 0 dekat dalam ni, you will get 0. Okay, you will get 0. So therefore, okay, balik semula kepada apa yang saya dah conclude kat sini. If you have your second derivative equals to 0, your test failed. Okay, your second derivative test failed. Therefore, we have to go back to our first derivative test. So here we know that our test failed. So how to go back to our first derivative test? We have to use the table. Okay, we have to use the table here. So we have our table here. So this is our interval, our test value, sin f prime x. Okay, this is the gradient lah. Okay, so the value here is only 0. Sebab ini tak ada masalah, ini dah settle. Okay, ini dah settle. For this part here settle. So here is negative infinity 0, here is 0 infinity, negative 1, 1. So the sign here, make sure to substitute negative 1 into first derivative. Okay, first derivative bukan second derivative, bukan original function. Sebab ini ialah first derivative test kita. Okay, first derivative test table. Okay, so now here you get the answer negative. Substitute 1 into here also will get you negative. So the gradient will be looking something like this. Okay, so remember back to our first derivative test, if the gradient doesn't change or the sign doesn't change, that means there is no relative extremum. So we can conclude that, mana soalan saya tadi? We can conclude that first, this part here, ini ialah minimum. Okay, we know that 3 pasangan dia ialah negative 27. 3 negative 27 is a minimum point, while our point 0, 0, there is no extremum, no relative extremum at 0, 0. And no relative extremum at 0, 0. Okay, so that is how you are going to write your answer. Okay, for 3 negative 27, that point is a minimum point, and for 0, 0, there is no relative extremum at 0, 0. So I know that by using second derivative test, it is much easier, but you have to know your first derivative test, because if the test fail, you have to go back to your first derivative test. Okay, so that is for 10.1. Critical point, find first derivative test, second derivative test. So this is your exit ticket for today's video. Okay, alright, so we are going to move on to the next video. Bye bye.